Down there, life continues. The traffic is awful, stocks go on trading, and Star Trek is still showing.
Good day, grade 8 learners. Welcome to today's natural sciences lesson. My name is Papuchezo Singo, and this lesson is proudly brought to you by the Harding Department of Education. In today's lesson, we're going to be learning under the knowledge area matter and materials. The topic is particle model of matter, and the subtopic is density of different materials and pressure of gases. Now, let's move on to the lesson objectives. At the end of the lesson, you should be able to define pressure, describe pressure in gases using the particle model of matter, describe factors that influence the pressure of a gas, and explain why some materials are denser than others. And all this is sourced from your CAPS document on page 44. Now let's cover pre-knowledge. So this is what we've learned prior to today's lesson. So far in the 8th grade, we've learned about the different states in which matter can exist. We've also learned about the first state, which is solids. Matter can exist as solids, the way particles are arranged in solids, and the spaces that exist between the particles and solids, and the energy that they possess. Next, we learned about liquids. We learned about how particles within liquids are arranged and the spaces between the particles. We also learned about gases, how particles within gases are arranged, and the big spaces that exist between gas particles. Now, let's move on to our baseline activity. So I'm going to read out these 4 questions and then give you time to answer. You can send in any questions you may have or responses to the baseline activity to our WhatsApp number, which is 079-572-2908. You will see it on the bottom of the screen. So here's the first question. Number 1, how can materials be made to change their state? Number 2, what are the 2 physical properties of a material that we need to determine its density? Number 3, what happens to the volume of ice when it melts into a liquid? Number 4, why does the liquid in a thermometer contract when put in cold water? Take 5 minutes to do this activity, and then after 5 minutes, we will do the corrections together. See you after 5 minutes. Welcome back, learners. Now let's answer those 4 questions. The first question read, how can material be made to change their state? Materials need to obtain energy or lose energy to change their state. So they need either to lose energy or to obtain energy in order for them to lose their state. Now let's answer the second question. What are the 2 physical properties of a material that we need to determine its density? The answer is we need to know its mass and volume. Question 3. What happens to the volume of ice when it melts into a liquid? What happens to the volume of ice when it melts into a liquid? The volume will decrease. And then why does the liquid in a thermometer contract when put in cold water? The particles lose energy and move less and more closely to each other. So they're going to lose energy. They move less and then they move more closely to each other, and the spaces between them, particles decrease. They decrease. So that's what happens when the liquid inside a thermometer contracts. Now take 1 minute to copy down these corrections. See you after 1 minute. Welcome back, learners. Now let's move on to terminology. Let's define the terms that we are going to come across in today's lesson. So the first term is density. Density is the amount of mass in each volume of matter. Dense, the amount of space an object takes up. And pressure, the force exerted per unit area. Collision, when 2 or more particles bump into each other. Now let's learn more about density. So far we know how to calculate density. We learned that when we did the density, mass and volume lesson. We calculated density, we did mass conversions and volume conversions, and we did calculations to determine volumes of regular shaped prisms and irregular shaped solids. Now, density. A material in its gas state has a much lower density. As per last week's lesson, we learned that gases in general have a much lower density. Why? Because of the way their particles are arranged. Their particles have huge spaces in between them, so they have large spaces between each particle. A gas's volume is not fixed. A gas will change its volume and fill up the space that it is put into, whereas the volume of a solid is fixed and the volume of a liquid is fixed. So, because of the arrangement of gas particles, now it lowers its density. So, gases are less dense in general. Now let's learn about density of different materials. So some materials have a low density, whereas other materials have a high density. It could be 2 solids that we're comparing, or it could be a solid and a liquid that we're comparing. Different materials have different densities. Others have low density, whereas others have a high density. For example, if we compare these two solids, the first solid is a loaf of bread and the second solid is a brick that is made of clay. The loaf of bread has a lower density than the clay brick, even though they are the same size or even though they have the same volume. Remember, how do we calculate volume? We'll say length multiplied by width and by height. Length multiplied by width and by height. So this is our loaf of bread and this is our brick. So even though the brick and the loaf of bread are the same size or have the same volume, they will have different densities. So now let's discover why and how. Now the density of a material depends on the kind of particles it is made up of and the size of space or the sizes of the spaces between the particles. Now, even though our brick and our loaf, when you look at them, they look the same size, they have the same volume. The brick is heavier and it is denser. This is due to the kind of particles that make up the brick and the spaces that exist between the particles that make up the brick. So for the same volume of material, your volume is your length multiplied by width multiplied by height. One metal tends to weigh less than the other. So if one metal has a lesser mass than the other, it will have a lesser density. So if the bread has a lesser mass, it's going to be less dense in comparison to the brick. So the density depends also on the kind of materials and the size of the spaces between them. So the kind of materials that the particle is made up of and the size of the spaces between them. Remember, we learned that the smallest unit of matter is what? It is an atom. An atom belongs to different elements, and different elements have different properties. So, two solids may have different densities. Okay, so a material that has small particles will have a smaller mass. So, and then it is also easy to fit many particles of some materials into a smaller space, and the particles of other materials may be too big and fewer will be able to fit into a certain space. I'm going to take you back to atoms. Atoms have different sizes. So look at it this way. So some materials may be made of particles or atoms that are much smaller. So they can be made to fit, you can make more of them fit into a space. And then some atoms are bigger because they have more number of electrons and protons. Now, and then which means those big atoms or those big molecules or those big compounds will be too big to fit into the same space, which means that you'll be able to fit fewer of them. So when we look at the brick that is made of clay, so the brick is made of clay and our bread is made from flour. Right. So the way the particles are packed into this brick and the way particles are packed into the bread makes their density also to be different. So if we put these following materials, they have the same volume, and then we measure their masses on a scale, do you think they're going to have the same density? If we take 1 cubic meter volume of coal with a mass of 1,700 kilograms, 1 cubic meter of feathers with a mass of 45 kilograms, 1 cubic meter volume of wood with a mass of 2,700 kgs and 1 cubic meter volume of water with a mass of 1,000 kilograms. If we take all these four materials and compare their densities, do you think they will have the same density? So all of them will have the same volume. So what do they have in common? They have the same volume in common, but they have different masses. Do you think they will have the same density? All right, let's find out. So the densities of the materials below. So here we go. Remember coal, we said coal has a volume of 1. All of them have a volume of 1 cubic meter, all of them, but their masses are different. Now, because their masses are different, they are going to have different densities. So, their mass depends on the type of particles that make up these materials, the spaces that exist between these particles. Are they bigger spaces or are they smaller spaces? Sometimes it's comparing a solid versus another solid and another solid. Or sometimes we're comparing the density of a liquid with a solid. So even though all these materials have the same volume, they will have different densities. Now let's look at this table here. So this table shows us different substances or different materials and their relative density in grams per cubic centimeter. So I'm going to pick out, so we've got alcohol here. Alcohol has a relative density of 0.82 grams per cubic centimeter. If we compare it with water, water at 4 degrees Celsius will have a density of 1 gram per cubic centimeter. These two, if you look at them, they are both liquids. These two are both liquids. They both exist as the same state, the alcohol and the water, but they have different densities. This is because of the size of the particles, the type of the particles, and the spaces that exist between the particles. If we compare water with a solid, we've got a solid here, rubber. Rubber has a density of 0.96, so which means that even though it is a solid, it is less dense than the water. Just like ice. Ice floats on top of water, which means ice is less dense than water, because when water freezes, the spaces between the particles or the water molecules, it increases, making ice less dense than liquid water. If we look at other solids as well, if we look at seawater, remember seawater is a mixture of different things. It is more dense than pure water. The solids, if you compare solids, aluminium with a density of 2.72 grams per cubic centimeter is less dense than lead, and lead has a density of 11.35. So different substances or different materials have different densities, and it all depends on the type of particles that make up that material and the spaces that exist. How big are these spaces that exist between the particles? Now, individual particles that make up one material may have different masses compared to individual particles that make up another material. So that's what makes one solid less dense than another solid. And in addition, the spaces between these particles differ as well. Now, the density of the material will depend on the kind of material that the particles are made of. So the kind of particles, are they hydrogen particles? Are they lead particles? Are they carbon dioxide particles? Are they nitrogen molecule particles? It will depend on the kind of particles it is made up of and the size of the spaces between them. So I have two solids here. So we've got table salt, which is our sodium chloride, and we've got cotton candy, a common delicacy that we enjoy. Now, these two are both solids. These two are both solids, but the way their particles are arranged and the size of the particles that make up these two solids is different. So they are bound to have different densities. If you look at table salt, and this is the way that the particles are arranged. If we look at cotton candy, which is another solid, this is the way the particles are arranged. As you can see, there is more space between the cotton candy particles in comparison to the particles of table salt. So which means that since these ones are more packed, it's going to be denser. It's going to be denser than cotton candy, whose particles have bigger spaces. So this covers the space part. Now the kind of particles is also different. So table salt is made of sodium chloride. Cotton candy is made of sugar. Right, of which sugar, we've got carbon, we've got hydrogen, and we have oxygen in it. So the type of particles is also different. Now let's learn about floating and sinking. Have you ever asked yourself, why does a log of wood float on water? But if you take a stone and you throw it into the water, it sinks. Why is it so? Now, this is because water has a higher density than wood, so the wood is going to float on the water. So a substance that has a lower density is going to float on a substance with a higher density. Now the stone has a higher density than the water, so the stone is going to sink. So a material with a lower density will float on a liquid that has a higher density. So there is a picture of logs of wood floating on water and then stones sinking in the water. So if a substance or solid has a lower density than water or a liquid, it is going to float. Next, which material will float on a liquid that has a higher density? Another example is oil. Oil is also a liquid, but oil has a lower density. That's why oil will float on water. If you pour oil into a glass of water, shake it for about a minute. At first it will look like the two mix, but if you let the mixture stand, you will see the oil will begin to go up and float on the water. Why? Because it has a lower density. So a material that has a lower density will float on a liquid which has a higher density. In this case is water. Now, gases, remember, they also have density. They also have a density even though their volume is not fixed. Now, a gas that has a lower density will float on a gas that has a higher density. This is the reason why hot air rises in cold air, and I'm sure you've seen it before. The particles of hot air are moving faster. They have more kinetic energy, so they are moving faster and they spread out, then making them less dense. That's why if you have a pot of water on the stove and when the water begins to boil and evaporate, that's why you see the steam going up. Steam never goes down. Steam always goes up because hot air is less dense than cold air. Why? The particles of hot air are moving faster, they have more kinetic energy, they are spreading out. The spaces between the particles are becoming larger and larger, making the hot air less dense. That's why you see steam rising up from a boiling pot of water. You see steam rising up from a boiling pot of water. Here I've got a density column just to showcase the density of different liquids that we have used at home or at school in our day-to-day living. Honey is, in this particular case, is the most dense liquid. That's why it is at the bottom of the column, followed by corn syrup, 100% maple syrup, milk, dish soap, water, vegetable oil, rubbing alcohol, and lamp oil. So here, water is less dense than honey, so water will float on top of honey. Lamp oil is less dense than water, so the lamp oil will float on the water. We also added some solids. There's a ping pong ball. It's less dense than all these liquids. It's less dense than all these liquids. Then we've got beads, a soda cap, and a cherry tomato, which has the same density. It's floating within the dish soap. It's floating within the dish soap. Now let's do this activity. I'm going to read out the questions and then give you time to answer them. Don't forget to send in any questions you may have or solutions to this activity to our WhatsApp number, which is at the bottom of the screen. Question 1. What are the two factors that influence density of a material? When will a solid float on a liquid? Number 3. Why does oil float on water? Number 4. Why are liquids less dense than solids? Number 5. What would happen if you poured old engine oil into a river? Give yourself 5 minutes to answer these questions. Then after 5 minutes, we will do the solutions together. See you after 5 minutes. Welcome back, learners. Now let's answer those questions. What are the two factors that influence the density of a material? It is the type of particles that the material is made of, the type of particles and the spaces between the particles. And then when a solid float on a liquid, a solid will float on a liquid when it is less dense, when its density is less than the density of a liquid. Take 1 minute to copy down these corrections. Welcome back, learners. Let's answer question 3 and 4. Why does oil float on water? Oil floats on water because oil is less dense than water. Oil is less dense than water, and while liquids less dense than solids, this is because their particles are much further apart than the particles of solids. Take 1 minute to copy down these corrections. Welcome back, learners. Let's answer question 5. What would happen if you poured all the engine oil into a river? The oil would spread out and cover all the water and the things below it. So the oil, remember, why? Oil is less dense than water. So oil floats on water regardless of whether it is engine oil, cooking oil, or sunflower oil. Oil floats on water. And rivers have water in them. They are water. So the engine oil is going to float on top of the water and spread out, covering all the things that are beneath it. As you can see in this diagram, all these black streaks, these are the oil that is floating on top of the body of water beneath it. Now take 1 minute to quickly copy down the solution. Welcome back, grade 8 learners. Let's move on to pressure. So far we learned about gases. They contain millions of fast-moving particles. Remember, all particles are in constant motion, but gas particles are moving fast. So they are fast-moving particles. They are moving everywhere, past each other, over each other, filling up the entire space. Now, gases have huge spaces between their particles. That's why they are less dense than solids and liquids. They have big spaces between their particles. And gas particles, we know they are in constant motion inside a container. So if you put a gas inside a container, it is going to be in constant motion. Look at these gas particles. They are in constant motion. They are moving quite fast. And as they are moving, they are bumping into each other and they are bumping into the sides of the container. They are fast moving. They are in constant motion. Now let's learn about pressure in gases. But first, what is pressure? Pressure is the force exerted per unit area. It is the force exerted per unit area. So a gas exerts pressure because of the collisions of the particles with each other and against the size of the container. Remember, they are moving fast. They are fast moving. The spaces between them are big. The forces of attraction between them are very weak. So they are moving very fast. They have kinetic energy. They are moving very fast. So as they move very fast, they are colliding with each other. And they're colliding with the sides of the container in which they are contained with. Now, the gas particles, we know that they are further apart because the spaces between the gases are quite large. Right, so let's say we've got a big flask. The gas particles in a bigger flask are going to be further apart and they will have fewer collisions with one another and with the sides of the container because they're further apart. There's so much space for them to be moving left, right, up and down. And the bigger flask will therefore exert a lower pressure. So when a gas exerts pressure, it is colliding with the sides of the container. We're counting the collisions with the sides of the container. How frequent are they? How many are they? So if you put a gas into a big flask, chances of the gas, or rather the number of collisions with the sides of the container is going to be less because the space or the volume of this container is quite large. If, however, it was a smaller container, the collisions were going to be more because there's less space. There's less space available. There's less volume available. So the chances that the gas particles will collide with each other and collide with the sides of the container increase. The number of the collisions also increases. Now, you are able to compress a gas. Why? Remember from our last lesson, we said gas particles have more spaces between them. So you can compress it. As you're compressing it, you are reducing the space that the gas is occupying. But because there are huge spaces between the gas particles anyway, you can compress it as much as you can. But with solids and with liquids, it may be difficult because the spaces between the particles of a solid and the particles of a liquid are already small. So trying to compress those two would be futile because there's nowhere else the particles can go. So how do you compress a gas? So when you take a soccer ball and you pump air into it. So when you pump air into a soccer ball or blow more air into a balloon, you are adding more particles of the gas into the soccer ball, into the balloon. But you cannot compress a solid. You can't add more particles here. There is no space But with the gas, you can add more particles or you can reduce the volume. You can compress it, you can reduce the volume. You can add more particles. You can increase pressure here, either by reducing the volume of the space occupied, which increases the chances of collision, or adding more particles here, which also increases the chances of collision. But with solids, you cannot add more particles here. It is already packed. The spaces between the solids are already small. So remember, pressure of a gas, we are counting the number of collisions with the side of the container. So how can we increase the pressure of a gas? We can increase the pressure of a gas in this way. We pump more gas into a container. We add more gas particles, thereby increasing the number of collisions. We can reduce the volume of the container, also increasing the number of collisions. So these two containers, they have the same number of particles. Container A and container B, they have the same number of particles, but what is the difference? Container A is said to have a low pressure. Why? Because the volume of the container which the gases occupy is bigger than the volume which the gas in container B is occupying. So it is at low pressure. B is at high pressure because the volume is less. So that's one way of increasing the pressure of the gas. If we want to increase the pressure in container A, what do? We can add more gas particles. We can add more gas particles. This way, we can increase the pressure in container A. We can increase the pressure on container A because we would have increased the number of the collisions with the sides of the container. Now, here's a tire here. To increase the pressure in this tire, we just need to add more. We need to add more. The volume of the size of the tire is the same. So we just need to add more gas into it. Then we increase pressure. Now, here is our second activity. Number 1, what is pressure? Number 2, what happens when many gas particles collide with the surface of an object? Number 3, what happens when you blow up a paper bag or a balloon, or when you pump air into a tire? Take 5 minutes to do this activity, and then after 5 minutes, we will do the solutions together. Welcome back, learners. Let's answer these questions. What is pressure? It is the force that gas particles exert on the sides of a container. What happens when many gas particles collide with the surface of an object? All gas particles together will exert a great force on the surface and the pressure will be high. Number 3, what happens when you blow up a paper bag or a balloon or when you pump air into a tire? Air particles are forced into the bag, balloon, or tire. The more you blow, the more particles are pushed into the bag, the balloon, or the tire. If there are more particles, there will be more collisions, and that means the pressure will be greater. Take 2 minutes to copy down these corrections, and I'll see you after 2 minutes. Welcome back, learners. Now let's wrap up our lesson. What did we learn today? We learned that different materials have different densities. If we compare one solid with another solid, they will have different densities. For example, feathers and coal, they will have different densities. This is because of how their particles are arranged and the mass of the individual particles, which is the size of the individual particles. This makes the density of different materials very different. So that's why you have two solids with two different densities. You have two liquids with totally different densities. And you will have two gases with totally different densities. This is because of the way the particles are arranged, the spaces, the sizes of the spaces between the particles, and the mass of the individual particle. What particle is it? Is it just a nitrogen molecule? Is it a carbon dioxide, a compound? Is it a water molecule? What type of particle is making up this substance? And substances like oil are less dense than water. Why? This is because of what we've just talked about. This is because of the way the particles are arranged and the spaces that exist between those individual particles. So oil will float on water. Even if you pour oil into a container with water, you shake it for a minute, the oil will still come up above the water and float on the water. Other substances that will float on water are wood, because wood is less dense than water. Then, in general, gases are less dense than liquids, and liquids are less dense than solids, with the exception of ice. Ice is less dense than water. Ice will float on water. You will have a big iceberg floating in the ocean. You will have ice cube floating in your cold drink or in your glass of water, because ice is less dense than water. Gas particles move around very fast. That's why you'll have a situation where hot air will float above cold air, or hot gas, hot water vapor will float on cold water vapor. They are moving very fast. They have more kinetic energy, and the spaces between them are more, which makes the steam less dense, which makes the hot water vapor less dense. Then inside of a container, gas particles, because they are moving so fast and they are in constant motion, they will collide with each other, and they will collide with the walls of the container. And this is what we call the pressure of a gas. This is the force that the gas will exert to the walls of the container, and we call this gas pressure. So gas pressure is the force that the gas particles exert on the walls of the container when they are constantly colliding with the sides of the container. Now, here is our homework activity. Take 2 minutes to copy down each of the 5 questions, and then we will call it a day. Welcome back, learners. Now we have come to the end of our lesson. Thank you so much for joining me in today's lesson. Bye-bye.